Great. So my name is Eran Messeri. I'm part of the browser infrastructure team at Google. It used to be the WebDriver team before WebDriver and Selenium merged, and then they merged, so it became the Selenium team. And then we took on responsibility, became the web testing team. But actually, we deal with everything that's related to browser provisioning inside Google, specifically for tests. I'm going to talk today about things that can go wrong with Selenium tests. I'm sure each and every one of you has their story about things that can go wrong. Maybe some of it I'll cover. If not, you're more than welcome to share the end. And just before I start, to figure out how many of you are like general software engineers, like people who don't have test or quality in their title, but care enough about it to attend? It's really good. Like test engineers or people who define themselves as manual testers. Okay, that's great. And how many of you maintain or have interacted with a large suite of Selenium tests? Okay, that's great. So yeah, the talk is hopefully for the people who dealt with large suites of Selenium tests, how to improve them, and for those who haven't, what to avoid when you build something like that. And what I'm going to talk about is things that can go wrong when you create large Selenium tests. And if I was only talking about what can go wrong, it would have been a rant, not a talk. So I'm going to say what you can do about it a bit as well. And I'm going to start with a tale of personal experience. I was at KubeCon, a software engineering conference a couple of years ago. One of the speakers was speaking about sort of continuous delivery using obviously like continuous builds to deploy several times a day as quickly as possible. Quite an interesting talk, and at the end I was waiting to chat to the guy. And another one, somebody else came, started to talk to him, and he was asking about their tests. And the speaker was Dan North, by the way, pretty good one. And he mentioned they don't have any Selenium tests as part of their sort of release, like testing and release process. And the other guy said, "Oh yeah, Selenium, it's terrible, it sucks, it's painful." At this point, obviously, he didn't know I'm a Selenium committer. So I introduced myself, said, "Hi, I'm one of the Selenium committers. What exactly is wrong? I mean, is it the API you don't like? We can fix it. Is it browser support that is not enough? We can fix that as well." So I thought for a minute and said, maybe because he felt the need to apologize. Actually, it's not Selenium itself. It's the infrastructure that our sort of automated testers build. Setting it up on my machine and running things is very, very difficult. And yeah, it's true. Like you need this setup stage. Like when you want to run or write a Selenium test, there is no avoiding that. You'll have to set up a browser this way or another. You'll have to get the Selenium installation itself on the machine. If these are new machines that you're provisioning, you'll have to do it automatically. If you have a sort of a farm or something like this, you'll have to maintain that. And it's necessary, and it is painful. And when you do that automatically, it's prone to failure. That's sort of one category of things. Now, I'm generally going to talk about flaky tests, and how I define flaky tests is tests which fail intermittently without any correlation to changes in the code under test. I think the opposite definition of stable test is more clear. Tests that only fail when the functionality they test breaks. So if you don't have a stable test, you have a flaky test. Doesn't matter what the reason, you have a flaky test.
What do you mean by failed?
Failed means you're running the tests. They fail. Like you fail, you get a red build. You get the test runner telling you one of the tests failed. One of them, all of them, it doesn't matter. They fail, and they fail, but they don't give you an indication of an actual breakage in the code. Okay, that's basically the problem of flaky tests. How many of you have experienced that? Okay, yes. I'm not surprised. Right, and obviously, like we want to battle that, right? Because like, developers will see, especially like on a large project where some people maintain the Selenium test suite, or at least the infrastructure that's used to write the Selenium tests, and most developers either build on the infrastructure or just interact with it by running it. They will come to the conclusion that they will say at some point that their Selenium tests are flaky. They could say it because there are some infrastructure problems with Selenium itself, like for example, trying to start a browser but failing. Or they could say that because the tests themselves are flaky. The test tries to find an element and click on it. Most of the time it succeeds, sometimes it doesn't. Right? So there could be two reasons, but ultimately they will forget the differentiation and they will be left with this statement: our Selenium tests are flaky. And I'm going to claim that flaky tests are even worse than unwritten tests. Why? Let's say you have like a web frontend for your application or a whole web application, and you release it and you don't have automated tests. So you say, okay, I know I should write some automated tests for this. I know I have Selenium, I know I have other tools. I can do that. I can improve my release process. So you have this hope. But if you do have Selenium tests and they are flaky, you say, okay, I've tried, I've spent some time, several people spend some time trying to stabilize these tests. They still sometimes fail. We don't get any value from them. There is no hope. I cannot test automatically my front end, my UI. And that's a pretty bad place to be in, right? Nobody wants to be there. So this is why we want to eliminate these false alarms on build breakages, like from Selenium tests. Specifically from Selenium tests, we want basically that when a test fails, it will be a real failure, right? If there are some underlying problems, they should be dealt with. They should be somehow marked so developers don't think there is a build as a test failure when there actually there isn't. Some numbers about how many web tests we run at Google. We have about 2.5 million browser sessions a day. A browser session maps roughly to a test or a test suite. Some tests request more than one browser session during their lifetime. Most tests share one session. So about 65% of these require a VM, so they are a Windows-based test, either IE or a Windows-based configuration of Firefox or Chrome or Opera. And the interesting thing is that 90% of these test runs pass, which sounds like a pretty good amount, right? I mean, most of the time, like 9 out of 10 times, it passes. But it should be like almost 100%, right? Most of these tests are run by an automated continuous build system, basically. So most of the time they should be green. Developers could run these tests, find some breakage, and then fix the cause for the breakage. But this should be the very, very small percentage of the cases, right? If you look at the number of cases, like it requires a lot of humans to generate this amount of traffic, right? Most of it is automated. So so it means that there is a lot of flakiness that we should deal with. About the infrastructure failure itself, and when I say infrastructure failure, I mean Selenium, like problems within Selenium or within our infrastructure in Google that starts up, that prepares the environment for Selenium, like browser, unpacking the browser or starting a VM and things like that. And the failure rate there is 0.0035%. Overall, a very small amount, right? So I think each of you, they see this number, they see the amount of browser sessions, they say, why would you even bother? I mean, it's like 100, 200 failures a day, like out of 2.5 million, like why? And the thing is that first of all, it wasn't always this low. It was much higher, like several orders of magnitude bigger, and we've worked very hard to improve that. But the other thing is that even with this small amount, we still have these like 100, 200 false notifications a day, and even if you take a very conservative estimation of 5 minutes of a developer's time to investigate each failure. So the developer gets an email, your project is broken. They have to look at the target that's broken. They have to look at the logs, dig through the stack trace, and say, okay, this is actually Selenium failing to start Firefox for me. I know this one. Or it could take even more because Selenium is used as a sort of browser driver for JavaScript tests. So somebody writes a JavaScript test, completely JavaScript, provides the JavaScript files, specifies a set of browsers they want to run their test against, run it, get a failure, and then when they look at the log, suddenly a wild JavaScript Java stack trace appears. They don't, I mean, it surprises them, right? They wrote JavaScript tests, not Java tests. They have a tool that runs their tests. They don't know what language it's written in. And suddenly it's Java, and they get a stack trace. They don't understand why it's failing, but it is failing. So it could take even more time to investigate this, and takes basically 1 or 2 engineering days a day are spent just figuring out what these failures are. And the worst problem for us is user confidence. We are, so as the browser infrastructure team in Google, we support all the other engineers who provision browsers for tests. And they would have occasionally came to us and say, have a look at this failure. It's not my fault. Something failed. Like, could you verify that it is like your fault, not our fault? And can you do something about it? So we reduced these failure rates and kept reducing it, but there were always developers saying, this is not our fault, this is WebDriver's or Selenium's fault. And let me tell you, most of the times it wasn't the case. So we wanted to something better. We wanted them not to see these failures at all. What are the things that we saw failing? We were unpacking Firefox, so we have sort of an Linux environment for running tests, distributed obviously. We were unpacking Firefox. Sometimes it would time out. We were starting Firefox, and that would time out sometimes. And we were giving a very generous amount of time, like 3 minutes for Firefox to start up, just for the Firefox window to pop open, not loading anything, nothing. And it wouldn't be enough. We discovered that some machines are very loaded sometimes, so loaded that the I/O that does the actual Firefox loading, like from the disk to the memory to execution, just didn't complete on time. We were sharing an X server. This was Linux environment, so we needed an X server for Firefox to display itself somewhere. This server was shared between browser sessions, like in the same test. And when this server was dead, Firefox obviously couldn't start, or could crash like mid-run, like mid-test. Doesn't happen often, but if you have an old version of Flash installed and you are testing something that has Flash in it, could happen. If we were in a VM, and as I mentioned, about 65% of the tests were in a VM, the VM could fail to start. Again, it could also happen in these magnitudes. Or even if the VM started, we would have to copy the Selenium jar into it. We wouldn't cache the Selenium jar in the VM so that when we upgraded the version of Selenium inside Google, we wouldn't have to update VM images and things like that. We could just put a new version of the jar in the central source repository and it will be picked up. So copying it into the VM could also fail. Several tens of megabytes, some transfers would fail. And there is a general infrastructure, or the way we provision browsers in Google, that added complexity. We have an sort of internal server that gets the request from the client code to provision a browser. Like client would say, give me IE8 on Windows XP, and that server will start a VM if needed, or if it's a Linux-based browser, we'll just unpack the browser and hand back the address of the remote WebDriver server to the client. Why is it good? Because if you have to support multiple languages, they all speak the same RPC implementation, so it's very convenient, to add support for Python or Go, which somebody actually did. But on the other hand, it adds complexity. These RPCs could time out, or this internal server could just fail to start. So again, exceptions that the developer or the user cannot do anything about, but they still see them. And how do we battle that? So first of all, and the most important thing is to fix the underlying cause. Start by fixing whatever you can. Before we look at workarounds and things to mitigate, just look into the cause and fix. And I can tell you we've spent many, many months going with a magnifying glass at each stack trace and each log to figure out exactly why things fail, and fix whatever we could. But then there are some ungovernable failures, these exceptions in Java that you catch, you have nothing to do about. I'll just throw it up. Somebody will deal with it. So in these cases, what we did is sort of label the test run actually, as the one that's failed because of an infrastructure issue. And when such a test run was labeled, when a test run was labeled such a way, we didn't show it to the end user. The end user wouldn't see a test failure. We would retry this run once in a totally different environment. And if it was still failing, we would just not use the result of this test run. We will say, okay, the status of this build is inconclusive at the moment. Maybe later when we'll run it again, it will give us a concrete result, either a real failure or a passing test. But we're not going to notify the developer that their tests are failing, because we don't know that for sure. We see an infrastructure problem. And then the last thing you can do is have a look at all the stack traces from all the test runs that failed and try to cluster similar stack traces and similar exceptions. This is sort of the last resort. Developer can take their exception and see if it is similar to other exceptions from this specific target or this specific project to other ones, and they can at least say maybe it's not recognized infrastructure failure, but it's something we've seen in the past, so there is obviously a problem. And this is a tool that is helpful when we deal with the tests themselves. Any questions so far? There will be some time for questions at the end, but you're more than welcome to ask if you have concrete question about specific slide. So that was one side, the infrastructure side, like when the infrastructure fails, the infrastructure disappoints us. We can deal with that. But some tests are just not well written. There's no escaping that. What can happen? First of all, everyone knows that timing is everything, and some tests just expect things to happen within a given time frame. They don't explicitly state this expectation. They just happen to work most of the time. The most, I think, common example is developers expecting that when a click call returns, if they were navigating to a different page or starting a sequence of events on the page, this sequence would end or the page would load when the click call returns. And this is something that could be true most of the time, except this one time where your network is slow or when your host is very busy, and things will take longer and then the test will fail. And then there is basically like the general bigger problem is explicit specification of the application state. If a test doesn't explicitly say, before I proceed to the next step, this is how I want the application to look, to behave, to be in this state, then most of the time the test will pass, except some cases where network connectivity is broken, something is broken, and then things will not load, and the test will just fail. It will be very difficult to figure out exactly why, especially like when you see an element not appearing or a page or being redirected to an interstitial page. I saw that actually in the Google Calendar's tests. They were running their tests automatically, and once in a while it was just failing, saying, oh, I can't find this element. It was just after the login screen. They were expecting, obviously, to find the main calendar screen. Sometimes just would fail. Turns out that there was sort of like an experiment that was running that would trigger in a very small percentage of the cases, but in these cases, it transferred the user to an interstitial page, saying you should update your phone or something like this. Maybe some of you have seen this screen, like when you log into Gmail or calendars after a long time, they say, is this your recovery phone? Just update it, and then you can continue. But if the test doesn't check for this state, isn't aware of this state, and more importantly, doesn't explicitly say, I've expected the main calendar screen to appear, but it hasn't appeared, then it's going to be very difficult, like debugging the test. You just see an exception saying, this element could not be found. You have no idea what the problem is. And the thing is that Selenium cannot really figure that out for you, especially when in terms of events being processed or something, or the page settling. It's what's called the halting problem, which, as some of you may know, it's an NP complete problem, very difficult to solve. Selenium can do that for you. Sorry. And then there is the issue of interacting with outside environment. Could appear in several forms. If your tests are accessing a public site, if your tests are accessing yahoo.com, and either yahoo.com is down, or your company's internet connectivity is down, or just your company's DNS server is not resolving yahoo.com properly, the test will fail. It's going to be a pain figuring out exactly when that happens, like in which circumstances. And then you could be testing against sort of a staging or queue environment. In other words, environment that you haven't set up yourself in the test, which could be in an inconsistent state between test runs. It's very convenient. I mean, it's painful to set up an environment just for the test. A lot of people say, okay, I'll just deploy to this environment and then run the test against this environment and it should be fine. And it is fine unless some developer really has to check something exactly on this, specifically on this environment, and then they change something and it just fails. And then there is all sorts of like ads or tracking code that is being fetched from third parties that most of the time is there quickly, but sometimes it's not there or just takes a very long time to load, and the test times out. How can you battle that? So you should specify explicitly the state of the application under test, either with implicit. If all you do is just wait for elements to appear, you can use implicit waits. Otherwise, if it's something more complex, like page title to be something or more complex sequence of tests, then you have the explicit waits that are in a WebDriver support package. There could be sort of invisible conditions, like For example, if you draw a button on the screen but hook the event handlers to this button only at a later stage, it could be that WebDriver will be fast enough to click on this button before the event handlers are hooked, and then nothing will happen. This is something that I've actually seen an application that behaves like that. Obviously, most users will not click this button within 200 milliseconds of it appearing, but Selenium will, and you will sometimes run into this problem. So you can run execute script or execute script asynchronously to figure out exactly what's the state of the underlying page. I think the best thing to do is have the application cooperate with the tests and make it visible or clear that it's ready to proceed. But you have a lot of tools to deal with different levels of cooperation of the application under test. And then you can just make sure that your tests are hermetic. It's very simple. You can just use a proxy to check or block access to external sites. We did this in Google. Daniel, who is around, did this and managed to improve the speed of our tests, like speed of a lot of tests significantly, because they were just loading, ads or tracking or the social widgets code that wasn't really necessary for the test. By blacklisting these requests, the test just didn't load these things and then just passed quickly. Very convenient. Yes?
I heard that Google is also using A/B testing, like serving a slightly different page to a small percentage of the users.
Mm-hmm.
How do you deal with that? Because you're suddenly seeing something different than users.
Yes. So I think the goal of A/B testing, right, is to see how users perceive the changes, not how an automated test deals with them. So I think the best way to do is just decide which version you want to serve and make sure the test expects this version. And if the versions are slightly different, then you have a lot of abstractions you can do to make sure that the test still behaves test the same behavior without having to change the underlying implementation details of which elements it finds and how it interacts with them directly.
So the front-end test should be able to say I want this exact version on the back end.
Yeah. Mm-hmm. Yes. So yes, I think the best tests we saw are those that set up a hermetic environment. They bring up their own server, and the server uses fake data stores, and they have the exact data they want in the data stores, and then the test runs against the front end that is served by this server that the test started up. So the test knows everything about the environment, no surprises. Okay? So to sum it up, the goal is to eliminate false failures from Selenium tests, right? Increase confidence, make sure developers, everybody takes the results of these tests seriously. These failures can originate from the infrastructure itself or from badly written tests. The failures that are related to the infrastructure, they should be fixed and properly labeled when you cannot recover from them. And the tests themselves, they should explicitly specify the state of the application under test and should be as hermetic as possible. Once you take these steps, presumably you profit from better street cred for your tests. Whoever takes them more seriously, I think this is the goal. Questions?
A small one. Currently at our company we have just a web JavaScript only developed application that runs within the side of the customer.
Mm-hmm.
But I was thinking we're using the hash for page changes, and we're running some problems with Selenium waiting until the page is loaded because we really don't determine when the page is done.
Mm-hmm.
But what we might be doing is, you already stated, you can ask the application if you're done loading this current page maybe.
Yes.
And then let Selenium interact with that.
Mm-hmm.
That would be a better solution, most likely, than waiting for a title to change or an element to appear, right?
Yes. If you can get the application to cooperate with you and tell you either through a user visible way or an invisible way, like some variable on the DOM, mm-hmm. something like this, to let you know that you can proceed, like the test can proceed, I think it's the best approach.
Okay. And also solve a lot of problems.
Yeah, exactly. Yes.
How does Google run the tests on the live side, or do they use great question?
So
do they use a separate device?
So if I understand correctly, the question is if it's run against the live site or testing versions, right?
Yeah.
So the goal, or at least what we aspire to tell our users to do, is start up their own server for the things they test. So Google Plus, for example, they start up a whole Google Plus server with, as I said, all the data stores and everything. It's a huge server. It takes obscene amount of memory, but it does make the test hermetic. Running against the live site gives little benefit because by the time it's pushed to the live site, the functionality should be working, right? I think some teams may use that may have like a subset of the test as probes just to make sure things are alive, but you should definitely catch the failures way before that. Okay, any more questions? Yes.
How do you organize your tests?
In what in what way? What do you mean?
Well, do you have just a bunch of tests, and how do you determine which set of tests is going to run? Or that's what I mean.
Yeah. Okay. So we have the concept of a target, which is basically, if you are familiar with Makefiles, it's something similar. And this target could group together many single tests. It's usually one target is mapped to a single test suite, and you can again like have one target depend on other targets, and each target is its own test suite. There are some things that can just go through the directory, collect all the tests, and generate on the fly a test suite out of that. We do distinguish between different test sizes: small ones, which are unit tests and cannot do things like writing the file system. Everything should be like in memory and quick. Medium ones, which can do file system or networking, but not a lot, should take under half a minute. And then the large ones, which is Selenium tests and everything else that starts servers and interacts with interaction with the components and things like that. Does that answer the question? If not, you can come later and ask. Yes.
One of your solutions to the basic problems with the test driveness was to make the application code collaborate with coordinate itself with Selenium. But some teams would say that this makes Selenium testing invasive. So how do you, well, of course you can argue that make the effort of making the application collaborate with Selenium testing makes it cheaper in the long run. But what is the, what are the easy wins? What are the easiest or cheapest application accommodations for Selenium that you in your experience you see that make it sort of yeah, it's going to cost to do something, but this is really cheap. You can just do it in a day.
Yeah. So I think in an ideal world, everything. So Selenium is testing the application from the user's point of view, right? So in an ideal world, there will be like user visible indication for every step. If the application is busy doing something, the controls will be disabled, and Selenium will not be able to interact with them. And if the page is ready, then there will be, I don't know, maybe a message saying like it's ready. You can see that on some of the Google properties, like Google Docs. If it's offline, all the controls will be disabled. And Gmail, if it experiences a problem, there will be a bar at the top saying that. I think this may be the most non-invasive way, and I think you should use like the more invasive ways of executing a script or querying the DOM directly, only on very specific cases, like if you really cannot determine through the UI or they don't want to expose this information to the UI. Does that answer the question?
Do you also have other examples or other techniques? Setting DOM variables.
One thing I found with some teams is that turns out automatability is the same problem as accessibility. So a screen reader can't use your application if Selenium can't read your application. So like the Gmail team, it turns out didn't used to be very accessible. They started using Selenium. Now they have accessibility tags everywhere, which means it's both readable from a screen reader and it gives them convenient hooks for Selenium to go, give me the thing which I meant to be typing a message into.
So,